As we continue our study of counting methods, there are two major topics that are left to talk about. These are permutations and combinations. Now, it turns out we've already done a permutation problem or two. We just haven't used that term before. Let me show you an example. We did this one earlier where we had a student club with 8 members, and we asked how many ways are there to select 3 of them, one to be the president, one to be the vice president, and one to be the treasurer. And to do this, we just used the product rule. We just said if you are selecting these 3 roles, you can select first the president, and there are 8 options for that. Then you can select the VP. Now there are 7 people left to choose from, assuming one person can't hold 2 roles. And then finally, there's 6 people left for the treasurer. So you can multiply these 3 together, and there's this kind of descending product that you start to notice. And it turns out that this is exactly what a permutation problem looks like in general, and we can talk about some kind of more general examples like this, but it turns out that any permutation problem that you run across, you can always just do it just like this. You can do this descending product where you think about selecting from the whole group to begin with, and then each time you have one fewer item to choose from. So the idea of a permutation, the kind of problem it is exactly this situation where you have a group of some size, so we'll call that n. N is the number of total options to choose from. And then what you're going to do is you're going to pick some subset of that. So we'll call this k, the number of objects that you select. And then the key is that once you do, there's some sort of arrangement to them. There's some sort of order to them. So when we talk about combinations in a minute, that's going to be the key difference between permutations and combinations. So the distinction is with permutations, there's some sort of order that's significant. So in the example we just did, it was significant who ended up being the president, who ended up being the vice president, and who ended up being the treasurer. If all we were interested in is selecting 3 members from the group with no sort of structure or order to them, we would be doing a combination problem, which we'll get to a little bit later on. But for now, this is the setup for a permutation problem. You have a group that you're selecting from, you select some subset of that, and you arrange them in order. So for example, let's say a really simple example. Suppose we want to arrange 5 people in order for a group photo. Well, there are 5 spots to fill. And since we're doing them in order, we can fill the first spot first. So there are 5 people that can go there, then 4, then 3, then 2, then 1. So each time we select somebody, there's 1 fewer person to choose from. And we have, again, this descending product that shows up. Now, of course, for a shorthand, we can write instead 5 factorial. We've talked about this before, but the factorial just means exactly this, that you start with 5 and then multiply by the next lowest integer all the way down to 1 for the factorial. And that turns out to be 120. So the only reason for this factorial notation is that it kind of shortens things, gives us a faster way to write something, and also in your calculator there's a option to do the factorial without having to type in 5 times 4 times 3 times 2 times 1. So if you had 15 options, you wouldn't want to write that whole product down. It'd be much easier to write 15 factorial. And I'll show you in the calculator, in a different video, I'll show you how to do the calculator method for this. So that will be for 5 people. Now let's change the problem a little bit, and let's say we select 3 people from the 5 and arrange them. So now we've only got 3 spots to fill. There are still 5 options for the first, 4 for the second, and 3 for the third. So notice how we have this descending product that gets sort of cut off after the 3. So just to show you this a little bit more clearly, let's say we had the 5 times 4 times 3, and there's this sort of phantom times 2 times 1 here at the end. All of this together forms 5 factorial, right? So 5 factorial is the part that we have in our answer, and also the 2 and the 1. So it turns out that this number here is going to be 5 factorial after we divide away this tail at the end of here. And this, if you notice, is just 2 factorial. So it turns out that 5 times 4 times 3 you can also write as 5 factorial divided by 2 factorial, which is kind of a shorthand, again, notation. And I'll write down a formula in a second for permutations that looks just like that. And it basically just gives you a quicker way to jump to the answer on one like these, or ones like these. Again, you can always set up the problem this way, where you think about multiplying in order with this descending product, but the formula basically captures all of that for you quicker in a more concise way. So the formula for permutations looks just like what we wrote down, where if you notice, the numerator is the factorial of the size of the group that we're choosing from, which if we go back here, remember that was n. So the numerator of our formula is going to be n factorial, the size of the group, factorial. And then if you notice, this denominator, the 2, that's how much is left over after we've selected our 3 slots. So there are 2 left over, and so that's going to be, it turns out, n minus k factorial. So that's the formula, and it looks scary when you first see it, but if you recognize that it just came from a setup that we're familiar with right here, it's a lot easier to see. So the formula, the notation here, P of nk is saying permutations where n is our group size and k is the number we select. That's going to be n factorial over n minus k factorial. Notice the parentheses there. So there's our formula. Not that you need to memorize a formula, but if it comes in handy just to save you some time on homework examples or on a test, that will be useful. So for our example, we had 5 as our group size. We selected 3, which is where we got the 5 factorial over 5 minus 3 factorial. And again, that works out to be 60, just in case you're interested. But the point of this example was just to show where this formula comes from, that it's not as obtuse as it looks at first. It comes from a familiar place in that sense.